This week, a special programme. Can artificial intelligence make healthcare better for all of us and save the NHS? Here in the UK, the National Health Service has been in crisis for many years, looking after an increasingly ageing population with complex needs. Fighting for resources, it's been at breaking point. And then, the pandemic hit.
There will come a moment when no health service in the world could possibly cope.
And indeed, many countries' health systems have struggled with the sheer number of COVID patients. Even those which didn't have people spilling out onto the streets had to put all other treatments on hold. The NHS is an old health system. In fact, it's several different systems that sometimes work together and sometimes don't. And now it's trying to reinvent itself and embrace technology to beat the queues that COVID-19 has created. This is a story I started filming just before the first UK lockdown, when we weren't yet wise to masks or social distancing, but there was definitely a hint that something was coming. I wanted to find out how artificial intelligence could be used to help take up the strain that the NHS was already under. And on what turned out to be my last day in London for many months, I found myself about to do something that I'd never done before. I wasn't nervous until I asked my Twitter followers what I can expect. Very loud noise, claustrophobia. Now I'm nervous. I'm going to have an MRI scan on my liver, and I have to lay absolutely still.
Yeah,
right.
And there's breathing instructions.
This magnetic resonance imaging scanner, MRI scanner, is going to be able to see my soft tissue and my fluid in great detail, and it will produce images like this, which will be looked at by a radiologist to try and work out if they can see anything unusual. Now, the thing produces really strong magnetic fields, which means nothing metal can come in. And that includes you. But this is no ordinary MRI scan. Instead of being read by a human, my MRI is going to be read by an artificial intelligence. This is a computer that will look at the images and read them at least as well as a human radiologist would.
Breathe out and hold your breath.
Now, this film is not about computers stealing jobs. This is a film about computers filling the gaps in an NHS that's short of money, short of nurses, and short of the highly skilled radiologists who can read and interpret images like these. But that's a really difficult job that takes years of training. I mean, how could you teach a computer to do that? Well, here's a classroom full of medical students, and this is a computer. The way you teach each is very different.
What you have in front of you here are CT scans of a human lung with cancerous tumours. I'll be teaching you how to identify them and hopefully save lives.
The human brain is brilliant at learning things. It can understand spoken words.
What are you looking for with the abnormality?
It can understand diagrams. Just through the teacher's descriptions, these students can have a good guess at finding tumours in these images. They get some right, and they get some wrong, but with repetition and practice, their brains make more and more connections, which strengthen with success until eventually we really understand the task in front of us, and we can do it well. But computers are dumb. They literally know nothing. They can't look at a diagram and imagine it in real life. They can't understand spoken words. Normal teaching methods won't work. So instead of trying to describe to them what we want them to learn, we teach them using trial and error. Millions of trials, in fact. The computer starts by circling completely random parts of the image. It just guesses. It doesn't even know what it's guessing at. All it knows is when its guess is right and when it's wrong. And mostly, because it's guessing, it's going to get it wrong. And the great thing about computers is they can do this over and over again really fast, and they remember everything. And every time it does accidentally get it right, it makes a connection to its previous correct guesses. With every right answer, certain connections get stronger. And with every wrong answer, others get weaker. Through this barrage of guesses, a network grows, similar to the human brain, which starts to distinguish between right and wrong. A digital thought process that we call a neural network. Until eventually, after a multitude of attempts, it has very few failures and a lot of success.
Okay, let's try some more difficult scans now.
So if we just take your gown off, Mandy.
And this is the technique that could help to relieve the pressure on the UK's breast screening service. Almost 1,000 women die from breast cancer in the UK every month. The aim is to catch the disease early when it's most treatable. But that means that more than 2 million women have their breasts scanned for potential cancer every year.
My entire role is clinical diagnostics within breast. You know, it takes up a great deal of my life. It's really important, and we're kind of fighting a big fight.
Bernadette works at the Lincolnshire Breast Screening Service, and she's part of a shrinking workforce. For years, the NHS has been unable to train or even recruit enough radiologists, and many services now face chronic staff shortages. This is further complicated by the fact that each mammogram needs to be read independently by at least 2 specialist clinicians.
So we have 2 people reading a mammogram because actually it's a really difficult process. Okay? What we're looking for is tiny, tiny cancers. Maybe, 2 millimetres. Maybe a little tiny smudge within a breast. And we're human, and some of us miss them. So that second read is that second opportunity to pick up that tiny little smudge that may, change a woman's life.
So, the Nottingham University Hospital has been trialling a new tool that may help. This is Mia, an AI trained to spot breast cancer. The aim of the project is for this system to be the second reader, potentially speeding up the whole process. So Mia's had a look at this mammogram as well. Can we have a look at what Mia thinks?
Sure. So on this particular case, Mia has actually marked the area that I've also been concerned about, and it actually makes a callback decision itself. And you can see there that Mia says callback malignancy because it's suspicious.
Its makers, Chiron Medical, have been developing Mia for over 3 years. Here in Nottingham, Jonathan and his team have been testing Mia on the hospital's historical datasets. These are the scans from women who've been to this clinic in the past and were diagnosed by a human. The aim is to see if Mia would have made the same decisions.
So this time, Mia hasn't actually placed any mark on the image here. And its opinion is no recall is required. Now actually this lady did come back for some extra tests, and this well-defined mass, she had an ultrasound when she came back, and this was a cyst, a perfectly harmless cyst. So I suppose the recall would be a false positive. This lady didn't actually need to come back.
A false positive is when the reader thinks that there's cancer, but on further investigation it turns out that they were wrong. And over at the Cambridge Breast Unit, Professor Fiona Gilbert has been conducting research to try and reduce those false positives. Something that not only puts a lot of strain on the system, but also a lot of strain on the patients.
It obviously causes quite a lot of distress to the women being called back, and the majority of them turn out to be normal. It's a lot of work for us to be assessing all these women for a relatively small number of cancers.
And when a programme screens over 2 million people every year, these little percentages do matter. Every year, around 70,000 women are given a false positive result, and some never attend a screening again. Fiona and her team have been testing an AI built by Google Health to see how the software compares to human radiologists.
So in the retrospective study that was done, the algorithm performed better than some of the individual radiologists and worse than other of the radiologists. So when they took the average performance of all the radiologists, the algorithm would have called back fewer people.
But this research project is still in its early stages, and it's set to move to the next phase of development this year. In the meantime, back in Nottingham, MIA has finished its initial trials and will now be tested in 15 more NHS sites against ongoing cases to make sure that it works.
Artificial intelligence is the next amazing transformation. So that's what excites me, and it excites me that I don't know the full potential. We know that the cancers we're missing tend to be smaller, they tend to be more aggressive, and those are the ones that we want to find.
But as the pandemic hit, all of this had to stop. And as breast clinics emptied out, elsewhere, the NHS was about to be overrun. The coronavirus pushed intensive care units beyond their limits. But even before the pandemic, these wards had been running at very near capacity. And it's here that one of the biggest killers in the UK, and indeed the world, lurks. It's called sepsis.
So sepsis is when there is a severe infection, and when the body's response to that severe infection leads to organ failure.
It can set in without warning and can affect anyone.
This is a lady in her early 50s. She's day 4 with us on the unit. She's very unwell initially.
People are admitted to ICUs for many reasons, but sepsis tends to strike when patients are at their weakest.
We literally collect every heartbeat and every breath. When you first start in intensive care, when I started, it was difficult to see what was important because there was so much data.
But remember, computers love data and love spotting patterns in it. They don't get tired and they never stop. So the doctors and computer scientists teamed up to create something called AI Clinician, an algorithm that can detect and even predict early signs of sepsis and then advise how to stop it.
What we've used is large databases with 20,000 patients, and then we tested it in another 80,000 patients. That's more than any doctor could see in their lifetime.
The trials were proving successful, but neither the AI nor the humans were ready for a new type of sepsis, one brought on by COVID-19.
There are a few differences. One is the intense inflammation they had in the lung made their oxygen levels really low, and so they needed high amounts of oxygen. They didn't tire of their breathing so quickly as many patients with other pneumonia often struggle with their breathing. We also saw things like a lot of blood clots, which we occasionally see in other sepsis, but were far more frequent in this disease.
Nearly all the patients coming through to ICU now had this new sepsis, and for the AI, this was an illness it had never seen before, nor had any data on. And remember, just because a computer's learned to be good at one task doesn't mean that it can do a different one. The AI clinician was back to square one. But the humans weren't. Their idea was to gather data from ICUs across the UK to create a database of treatments that worked, so the doctors in the thick of it could learn from each other at speed and save their patients.
We built for the first time a picture of how disease was treated in real time on a daily basis across the country. And you see all the diversity of all the different approaches people were trying, what was working, what was not working.
Now, this data will be used to retrain AI clinician, and one day it may help to treat sepsis that's caused by COVID.
So it's about 18 months since we started making this programme, and in that time we've all started to use technology in new ways, and some of that has included GP consultations over video call, for example. So I think it probably means that many of us will be happy to accept medical help from machines and computers in the future. But for those computers to be good at their jobs, they are going to need a lot of data, a lot of our personal medical data. Many services like Instagram, Google and Facebook don't charge us any money. Instead, they get to use our personal data to try and work out how better to target us with ads. For many of us, that seems like a fair exchange. They make our lives easier and they connect us to the world. But now, those same companies which have been collecting and profiting from our personal data are moving into healthcare. Amazon, Microsoft and Google are all trying to grab a seat at the table and dine on our medical data. And the NHS has something unique to offer. A whole nation's information from birth to death. And that's something that might make one feel uncomfortable.
I don't think many health professionals sit down with their patients and say, do you want your data to be sold to Google or DeepMind? I don't think those kind of conversations are being had.
And we're not just talking about the big household tech names here either. Plenty of other companies that you'd never have heard of also want access too.
The issue of sale of data to technology companies is an interesting and controversial issue. There are some people who believe it's an asset to the NHS and we should sell it. There are other people who believe that in some way or other that's a wrong thing to do from a moral point of view.
But if we get it right, and it is a big if, the benefits could be huge. A unified, joined up store of medical data could really speed up research and lead to new treatments. And AI would be used to look for the patterns hidden within. And that's something that could soon be helping those who are suffering from long COVID.
Thanks to artificial intelligence, we were able to link patient records with imaging and produce an analysis of 41,000 patients, imaging and clinical associations in about 2 months.
Adriana Roca is part of a team that's been looking into why long COVID only affects some people.
What we found was quite important and shocking because it was actually not obesity per se, but fatty liver disease linked to obesity, what was increasing the risk actually up to 5 times of being severe with COVID-19.
Ajay Agadi is one of almost 1 million people suffering from long COVID in the UK. He's 40 and a doctor, and he moved to the UK from India to complete his specialist training.
So in the last week of March, I was on the weekend duties and I was not feeling well. I went back home immediately. I self-isolated and then I was tested positive. I wasn't thinking that this virus will affect me because I was a fit adult and I thought it would be just okay like any other flu viruses for me. There was a moment when I thought I will just die, and I had 3 years old, which I have not, and I will not be able to see her ever in my life. I never knew that this virus will leave me or others with so many problems and disabilities even after 1 year.
So to understand his illness more, Ajay signed up to a study aiming to help long COVID patients. A trial that's using the very same AI that lured me into that big magnetic tube earlier. This AI had originally taught itself how to spot certain liver characteristics. As well as spotting unusual masses, it had also learned to assess the overall health of the liver. And here's what it made of mine.
Here we've picked up a small area, which is just a cyst, a simple fluid-filled sac.
And the AI has picked that up as something unusual, something of interest?
Yes,
Okay.
but there's no concerning features to it and we wouldn't survey it. And otherwise it's a very reassuring scan with no increased evidence of inflammation or scarring, iron or increased risk of fat.
But here's the thing. It turns out that because this AI can assess the overall health of the liver, it can do the same for other organs too.
And so we expanded first to organs like the kidneys, the pancreas, the spleen and the heart. Originally with the aim of looking at type 2 diabetes, but it turned out that a lot of those organs were actually being affected by COVID as well. If it was a radiographer manually analysing data from say 6 different organs, that could be up to about 24 man-hours of work. So what this allows us to do is basically automate some of the most labour-intensive parts of the process.
We are trying to identify which kind of fat is the one that puts you at risk. It's not obesity as we thought up until now. What makes you at higher risk is the visceral fat, the fat in the organs. Whereas we have found also people with low BMI with high fats in the liver.
Ajay is part of the clinical trial which may show that young, fit people with a normal BMI can also get long COVID if they have fat in their organs.
And not everyone is aware about what exactly long COVID is. But I think eventually when the acute things weans off, I think more and more people will come up with long COVID.
There are many trials in the country trying to understand long COVID, and artificial intelligence has become a big tool in the race to find a treatment. But for many, help can't come quick enough.
Technologies that bring about big change also bring new problems. There's no point denying that. But right now, AI is changing the world and opening up possibilities for huge medical breakthroughs. I mean, it helped us to develop highly effective vaccines in record time. So, I know the pandemic is far from over, but I still feel kind of lucky that it happened now rather than even just a decade ago. And maybe it will mean the NHS is a bit more ready for the next one.